So in this session, we'll discuss questions related to topic momentum. As you can see in the first question, two objects are there traveling directly towards each other and then they collide. So there are two objects. The best thing is you try to draw the figure so that you can understand the concept. So they're moving directly towards each other. So there's a head-on collision. The object A has a mass of 2 kilograms, initially traveling towards right with a speed of 3 meters per second. And object B has a mass of 5 kilograms. Object B is heavier. It should appear heavy. So that is having a mass of 5 kilograms and it is moving towards left with a speed of 2 meters per second. They're asking what is the total momentum of A and B after collision. And as we know, the total momentum before collision is equals to total momentum after collision. But the two objects as they're direct and they collide, so we have to consider the direction in which they move. So the total momentum before collision or the sum of momentum before the collision is equals to sum of momentum after the collision. So how we can work out this? If one of the direction like right hand side I consider as positive, the left hand side will be negative. So it will be 2 multiplied by 3, that is 6, plus 5 multiplied by minus 2, so it will be minus 10. And this is the momentum. We are finding total momentum after collision. So this x we are finding. So it will be 6 minus 10, 6 minus 10. So x is equals to minus 4. So what is the meaning of the minus 4? As you can see, the direction which we consider the positive direction to be right and we consider negative one to be left. And our final answer is negative. So our final answer is negative. What it shows that options with left should be the answer. And what about the magnitude? The magnitude is 4. That is why A is the right answer. Is it clear, discussion? The next question, the photograph shows a fireboat used to put out fires on a ship at sea. The pump fixed to a boat, the pump is there fixed to a boat, pumps the water from a sea. The seawater is projected at a high speed and out of the pipe to the, which is connected to a pump. So in the first part, they're asking the mass of a seawater which is pumped each second is 300 kg. That's a mass. The pipe has a diameter of 10 centimeter and the density of the seawater is 1030. We have to calculate the speed at which the seawater is projected from a pipe. We have to show that it is about 37 meter per second. So first what we do, we'll find what is the volume of the seawater coming out every second. So we have the formula, density is mass present in a unit volume. So volume is equals to mass divided by density. Mass of the seawater is 300 and the density is 1030. Because this is a mass pumped each second, so when we calculate this volume, what we'll get, this will be the volume which is coming out every second. So what is the volume coming out every second? What's the answer? 300 divided by 1030. So this will be 0.29 kilogram per second. Why kilogram per second? Because that's a, sorry, meter cube per second. Because that's a volume which is coming out. Now, to get the velocity, because what is velocity? Velocity is, or speed is, distance divided by time. So to calculate the speed, we have the volume which is flowing every second. So we have the rate of flow or rate of change in the volume. And if we multiply it by area, or if we divide it by area, not multiply it, if we divide by area, so what we will get, because this is meter cube, volume is in meter cube, time is in second, and area is meter square. So when we simplify this equation, our final answer will be meter per second. So basically what we get, we will get the speed. So volume divided by area will give us the length, and length divided by time will give us the speed. So what we will do, we have the volume per second, that is 0.29. We need area only. How to calculate the area? Diameter is given. So area is equals to pi r square. So area is equals to pi r square, where pi is 3.14, and radius, this is a diameter, radius will be 5 centimeter, but that is in centimeter, we have to convert into meter, so 0.05 square. So 3.14 multiplied by 0.05 square, what is the result? Answer. That will give us the area, that is 7.85 into 10 to the power minus 3 meters square. And now we need the speed. So how to get the speed? That is the volume flow divided by area. So the volume flow was 0.291 and the area is 7.85 into 10 to the power minus 3. That is equivalent to 37 meter per second. Is it clear, this question? That how we work out how much water is coming out every second, or what is the length covered every second by this water coming out from the pipe? Yeah, we need the time, that's right. But if you check in the question, the time is 1 second, because this is a mass per second. So when we use the formula densities, so when we use this formula density is mass over volume, and we got the volume which is mass divided by density. So actually, because this mass was mass per second and 1 second, so what about the volume? It will be volume per second. So when we are finding the speed, we mention volume divided by time, and that is divided by area. But because the time is 1 second, so it does not make difference to our calculation. It will be volume flow divided by area, we'll get the speed, as the time in the question is 1 second. Then another question, determine the rate at which the momentum of a seawater change by the pump. You may assume that the seawater is initially stationary. So seawater is initially stationary and it is coming out with a speed of 37 meter per second, and we know the mass, it is 300 kg. So to calculate the rate of change in momentum, There are two formulas. One is force into time, and the other one is the change in momentum divided by time interval. So rate of change in momentum equal to mv minus mu divided by the time, which is t. So this water is coming out at a speed of 37. The mass of the water is 300, so 300 multiplied by 37 minus 300 multiplied by 0. Why? Because they mentioned in the question, initially you consider water is at rest, not moving, stationary. And what about the time interval? As they mentioned, that's a mass every second, so time interval is 1. So 300 multiplied by 37, that will be how much? 11,100. And because it's a change in momentum, you can write kilogram meter per second square. It's a rate of change in momentum, or even you can write Newton, because the rate of change in momentum is actually the force. So we can say Newton. If it was only change in momentum, then it will be kilogram meter per second or Newton second. Projecting water from the pipe causes a force to be exerted on the pump. Explain the direction of the force on the pump. Like example, a pump is there, the water is coming out. So they're asking what is the direction of the force on the pump. So how we can work out the direction of force on the pump? So basically the pump will apply forward force on water, and according to Newton's third law, there will be equal and opposite force. So the water applies force to the pump in opposite direction, or opposite to the water flow. Is it clear? Discussion that as the water is coming out, the pump is pushing the water out, and as a result, the water particle will apply equal opposite force. Then the next question, initially the pump is turned off and the fireboard move forward through the water at a constant speed. The boat engine provide a constant force. When a pump is turned on, the water is projected forward and the fireboard slow down to a lower constant speed. Explain why the boat has now a lower constant speed, and your answer should refer all the horizontal forces acting. So what they mean here in the question, initially the pump is turned off. So pump is not working, the fireboard is moving forward. So it was moving forward at a constant speed. Speed was not changing. The boat engine provide a constant forward force. Then what they mentioned, when the pump is turned on, the moment we turn on the pump, the water is projected forward, the water is coming out from the pump. Which is projected forward As a result, what we observe the pump is turned on, water is projected, the fire would slow down to lower constant speed. It is moving at a constant speed, but this constant speed is a lower constant speed. So we have to explain this idea why the constant speed is lower. So initially, first thing, when the speed is constant, it means there is no resultant force acting on the board. So resultant force on the board is zero. Or we can say the initially the forward force is equals to the drag force. So there's a forward force acting, and that is balances with the drag force, the force which is opposing the motion. Then what happened? The moment when the pump is turned on, pump is switched on, so the pump is exerting force on the water, and the water is exerting force on the pump, so it means it created a force in backward direction, opposite direction. So when the pump is switched on, the force, the backward force act on the board. So it slow down, which reduce the drag as well. And once the drag balances with, so the forces which are acting, number one, the forward force is there, F, drag. Here also what happened, when the pump is switched on, so there's a backward force, and due to this backward force, the resultant force is backward or opposite to direction of the motion. That's why the reason, because the boat is there moving on the surface of the water, that's why uh, we specifically use the term drag. Air resistance is there when the object is moving through the air, but in case, you can say friction force of the water, you can also say drag force, but air resistance is not there. Yeah, it's not the right way to use, because the greater force which opposes the motion is the force from the water. And the drag force directly proportional to speed. If object is moving at a higher speed, drag is greater. Is it clear, this question? Another question, structure question related to topic. A game is played where each player uses a mallet to hit a disc across the table into the opponent goal. One player accidentally let go a mallet. The mallet travel at a speed of 1.6 and collide with the stationary disc. After the collision, the mallet continue in the same direction. We have to with a lower speed of 0.3, we have to calculate the speed at which the disk is moving. So according to conservation of the momentum, the total momentum before collision is equals to total momentum after collision. So here, what is the momentum of the mallet? That is 0.17 multiplied by 1.6. And what is the momentum of the disk? That is 0.035 multiplied by 0, because it is stationary. Same way, the mallet mass is 0.17 multiplied by 0.3, and for disk it is 0.035 multiplied by V. So according to conservation of the momentum, the total momentum before collision is equals to total momentum after the collision. So when we use these values, so it will be 0.17 into 1.6 equal plus 0 is equals to 0.17 multiplied by 0.3 plus 0.035 multiplied by V. So we'll solve for V, the speed at which the disk will move. So after substituting the value, it will come out as 6.3 meter per second. Is it clear? Discussion about the conservation of the momentum. The next part is basically related to the conservation of energy. In question 4, a car travel north with a velocity of 50. While still traveling in north, the car slowed down to a velocity of 20. Which of the following is a change in the velocity? So originally it was moving with 50 and now it changes to or decreases to 20. But direction does not change. So change in velocity is final minus initial. So that is equals to minus 30. So V will be the right answer. And question 5, which of the following quantity has SI base unit kilogram meter square second minus 3? How to work out this? Simply using a formula. Force is Newton, unit is Newton, a formula is MA. So mass is kilogram, expression is meter per second square, so it will be kilogram meter second minus 2. So it cannot be force. Momentum, which is a product of mass and velocity. So mass is kilogram, velocity is meter per second. So it will be equivalent to kilogram meter second minus 1. Power, it is force into distance divided by time, and force, it is kilogram meter per second square, distance is meter, and time is second. So when we simplify this, it will be kilogram meter square, and this second is there because this is kilogram meter per second square or minus 2. So this will move up, so it will be second minus 3. So what is the unit kilogram meter square second minus 3? That is equivalent to power. Is it clear? Question 5. And for work done, how to work out the SI base unit? It is force into distance. So force is Newton or kilogram meter second minus 2, and distance is meter, so it will be kilogram meter square second minus 2 as well. That's why C is the right answer. So these are some questions related to topic momentum. In the next session, we'll discuss more questions from this topic.